Hello everyone, welcome to Quant 200 series, where today we are going to discuss an amazing question based on integral solutions in linear equations. So first try this question and then we are going to solve it together. Okay, let's try this one. In a bag, there are 100 coins. The coins in the bag are of denomination 1 rupees, 2 rupees or 5 rupees. There are at least 10 coins and at most 60 coins of each denomination. Urvashi takes out 40 coins which consist at least one coin of each denomination from the bag and finds that the total worth of coins that she has taken out is 148 rupees. The total worth of coins that are still in the bag is 212. Which of the following can be the total number of coins of denomination rupees 1 that are still in the bag? So what can we say? C taken out 148 rupees. C is still left with 212. So total amount that we have here is equal to 212 plus 148, which is equal to 360 rupees. Now let's say number of coins of 1 rupees is X, number of coins of 2 rupees is Y, and number of total coins of 5 rupees is Z. Can I say that X plus Y plus Z should be equal to 100 as well as the total values? So X coin 1 rupee, value will be X rupees. Y coins of 2 rupees, the value will be 2Y rupees. Z coins of 3 rupees, 5 rupees, value will be 5Z, and this should be equal to 360. Now if we subtract equation 1 in equation 2, what are we getting? X will be cancelled out. Y plus 4Z will be equal to 260. Now minimum is 10, right? If I am putting minimum 10, which is equal to 40, Z is 40, then Y will be equal to 220, which is not possible because X plus Y plus Z is 100. So let's start with maximum values. What we can say about X, Y and Z here? The maximum value of Z that I can take is 60, at most 60 coin. If I'm taking Z as 60, this will become 240. In that case, Y will be 20. X plus Y plus Z is 100. Can I say X will be 20 as well? Now, we can reduce the value of Y, value of Z with the coefficient of Y and increase the value of Y with the coefficient of Z. This is the nature of the values of the variables in integral solutions. So if I put next value of Z, which is 59, Y will be 24 and X will be 24 plus 59 is 83. This will be 17. The next value, this we can take 58. This will be 28 and this will be 14. Then again, the next value we can take here is 57. This will be 32 and this will be 11. Now, can we go beyond that? No. Why? Because if you are taking Z is equal to 56, Y will be 36 and X will be less than 10, which is not possible because at least 10 coins are there. So there are 4 possibilities, 4 combination possible where sum of all the coins is 100 and their values is 360. Now, C is taking out at least one of each coin and total is 40 coins and total value is 148. So let's say in this case, number of 1 rupee coin is A, number of 2 rupees coin is B, and number of 3 rupees coin, not 3, again 5 rupees coin is C. Then total number of coins should be 40. Let's say this is our equation 3. What will be the total values? A plus 2B plus 5C is equal to 148. This is our 4th equation. Now once again, if I subtract equation 3 to equation 4, what are we getting? we get B plus 4C is equal to 108, right? Again, starting with the maximum value, let's try to check the combination, the possible values of A, B, C. We know that each of these values must be at least 1. Maximum value of C I can take is 27, but if I am taking C as 27, B will become 0. So that is not possible. I must take C at max 26. Then B will become 4. 26 into 4, 104, B is 4. Total is 40, so A must be 10. If A is 10, next value I can take C, decrease it with the coefficient of B, which will be 25, increase it with the coefficient of C, which will be 8, and decrease it by 3, because if this is 25 and 8, it will be a total of 33, then this will be 7. This value is increasing by 4, this value is decreasing by 1, 4 minus 1, this value will keep decreasing by 3. So next it will be 24, then 12, and then 4. Then this value we can take 23, this value is 16, and this value will be 1. Now we cannot go beyond that, because in that if you go beyond, if this becomes 22, this will be 20, sum will be 42, which is not possible. Now it says which of the following can be the total number of coins of denomination 1 rupees that are still in the bag. So we can consider one of the cases from here and one of the cases from here which satisfies all the condition. So you can see the value of C is always lesser here than this one. The value of B is always lesser here than this one, and value of A is always lesser here than this one. So any combination from here and any combination from here is possible. What could be the total number of coins of denomination 1? See, it could be 20 minus 10, 10, 20 minus 7, 13, 20 minus 4, 16, 20 minus 1, 19. Similarly, in all the cases, we will have to check. But do we need to check like this, or should we go by the options? Let's try to check if one value out of these 4 and one value out of these 4 gives us a difference of 9, because this is the total, this has been taken out. 9, 20 minus 9 is 11, there is no 11 here. 17 minus 9 is 8, there is no 8 here. 14 minus 9 is 5, there is no 5 here. 11 minus 9 is 2, there is no 2 here. Next option, 17, 20 minus 3, no 3 here. 17 minus 0, that is not possible. 14 and 11 is always not possible. Now consider 11. 11 cannot be left. If we check in case of 11, 20 minus 9 should be 11, not possible. 17 minus 11 will be 6, no 6 is here. 14 minus 3 is 11, there is again no 3 here. 11 minus 11 is 0, which is of course not going to happen. 13, 20 minus 13 is 7. Is there a 7? Yes, this is possible. Then there are multiple cases possible, like 17 minus 4 is also 13. 14 minus 1 is also 13. So there are multiple cases possible where number of coins left in this bag will be 1 rupee coin will be 13. So our answer is option D. It's a really good question based on finding the integral solutions in linear equations, which can be solved easily if you are familiar with how to find integral solutions quickly. If you know one integral solution, like one value should be decreasing by the coefficient of other variable and other value should be increasing with the coefficient of first variable, right? Thank you.